Right, we are trying to graph this function, negative 2x divided by x minus 2 squared. And a couple things to just take a look at is this rational function, the degree of the numerator would be 1. What's the degree of the denominator? I might be tempted to say 1, but if you were to square this out, you'd realize, oh, this is obviously a quadratic expression, and so it's going to have a degree of 2. So right away you can say, okay, the degree of the numerator is less than the degree of the denominator, so I can start thinking about what that means as far as what my graph will look like. And then I can start looking at the asymptotes. Let's first look at the vertical asymptote. So that's going to be the x value for which my function is undefined. And essentially what that is asking is, when will my denominator equal 0? That will be undefined, and that is when x is equal to 2. Pretty easy to see that right there. The next piece that I'm looking for is, what are my horizontal? What's my horizontal asymptote? And for my horizontal asymptote, I could recognize this right away, but let's just go ahead and assume we don't, and kind of go through the steps. It's helpful here to actually expand out our function. So we have negative 2x over, and what's x minus 2 squared? Well, it's x minus 2 times x minus 2, which is just x squared minus 4x plus 4. And now you should be starting to see it a lot more clearly, and perhaps we're not, that's okay. But the key piece here is that I have x here, but x squared in the denominator. So what's going to be happening as x is approaching positive and negative infinity? And let's just say that we still don't see it, so let's go ahead and simplify more by dividing my numerator by my denominator. So we're going to divide negative 2x by x squared minus 4x plus 4. And right away you should notice, what can I multiply x squared by to get negative 2x? Nothing. There's absolutely nothing I can multiply by. That's why it goes in 0 times, and it's going to have a remainder of, well, it's pretty clear. When I multiply my x squared polynomial by 0, I get 0. And when I subtract, I'm left with negative 2x. And so that's my remainder. So my simplified form of my function is just 0 plus the remainder, negative 2x over x squared minus 4x plus 4. And here it might be even more obvious to you that what's happening as x gets really, really large. Well, this whole piece here is just going to 0, and so all I'm left with is 0 itself, right? Because if you consider the numerator, x will get very, very large. Okay, we'll have 2 times that number. In the denominator, well, as x gets very, very, very big, the 4 is going to not really matter a whole lot. In fact, the x won't really matter a whole lot either. All that we're going to end up having is this huge x squared term. And so even as this piece up here is getting big, this piece down here is getting so much bigger that as I approach infinity, since I'm squaring the bottom and not squaring the top, this whole thing is going to go to 0. And you could try some values. You could plug in, x equal 100, then try it with 1,000, then try it maybe with 1,000,000, and see how close it is getting to 0. It'll just keep going and going and going until we're infinitesimally close to 0. And so my horizontal asymptote is just going to be y equals 0. And perhaps you're still a little concerned about why this works, and we could simplify it even more. And to think about how we would be simplifying this even more, we could divide everything on the top by x and everything on the bottom by x. I'll show you what I mean by that. let me bring this down here. So I divide both the top and the bottom by x, and I can do that as long as I do the same thing to the top as I do to the bottom. Everything's okay. So I'll have negative 2 x divided by x as my numerator, and on my denominator I'll have x squared divided by x minus 4x divided by x plus 4 over x. And now I can just do some nifty cancellation, right? X divided by x cancels. X squared divided by x is just x, and 4x divided by x is just 4. And of course, 4 over x, well, I'll just leave that alone. So now think about what I've got. I have negative 2 divided by x minus 4 plus 4 over x. What happens is x gets very, very, very large, and this should be very easy to see. I'll even write this out again. I have negative 2 divided by x minus 4 plus 4 over x. And remember, all I did was divide by x on the top and divide by x on the bottom. And I can see here that the numerator is staying the same. It's always going to be negative 2. And my denominator is going to be getting, well, what's going to be happening? This x term is going to be getting huge. 4 over x isn't going to matter. It's going to go to 0. And negative 4 is not really going to matter. This term is going to be approaching infinity. Okay, so as x approaches infinity, my function here is going to approach 0. Right? It's going to be getting very, very, very close to 0. So my horizontal asymptote is 0. All right, so now I am almost ready to graph my function. I want to consider what lastly, my critical points are. So the critical points I want to think about, first one is where my function is undefined. And I might as well just start my graph here. Where is my function undefined? Well, it's undefined when x is positive 2. And the horizontal asymptote is at y equals 0. And remember, that just tells me what's happening far out when I approach positive or negative infinity. I guess I should put the absolute value signs there. And so now the critical points that I'm looking for are not just where it's undefined, but also where my numerator is 0, where my roots occur. So what will make my numerator 0? That's pretty easy to see. I really only have one option. Negative 2x will be 0 when x equals 0. So my root is going to occur at the origin, at 0, 0. All right, when I plug in 0, I'm going to get 0. All right, so now all I've got to do is create my sign diagram so I can kind of figure out, okay, well, this is my root. It passes through here. As I move towards infinity, it's going to approach 0. And the really only the question is, okay, what happens over here, right? I know that I'm either going to be approaching infinity, positive infinity, or I'm going to be approaching negative infinity as I approach negative 2. And I know that I'm doing that either on this side or like that on that side. So I've got to figure out which is which. And I should probably not make that sign diagram there. Let's go ahead and make our sign diagram right here. All right, so my first critical point is at 0. It's my root. And my second critical point is at 2. And I want to know what's going on after that. So think first about what happens to the left of 0. Let's just plug in negative 1. And if you were to plug in negative 1, think about it, you would get negative 2 times negative 1, which is a positive value. And on the bottom, you're squaring. So the denominator is always going to be positive. Don't need to worry about that. So I will have a positive over a positive. And so to the left of my denominator, to the left of my root, everything is going to be positive. And think about what that means. If everything to the left of my root is positive, I can never go negative because that would be another root. That's not the case. So it's going to be positive and it's going to approach 0 as x gets closer and closer to infinity. All right, so that's my sign to the left of 0. Now what about between 0 and 2, right? I know it's positive, it's positive, it's positive, hits the root. Now the question is, does it go up towards positive infinity, or does it go down towards negative infinity? So I plug in, let's say 1. I'll have negative 2 times 1. That's going to be negative over a positive, which is going to be negative. So I know now that my function will look like that. On the left side of 2, and now to the right side of 2, let's plug in 3. If I plug in 3, I'm going to get negative 2 times 3, which is negative, over a positive again because of the squared, and again I'm going to have a negative value. And so this, you've got to be very careful here, because in thinking about how we graph this function, we know it's going to be negative everywhere to the left. It can never be positive, or else it would have to cross, because I know it's negative at 3, would have to cross the x-axis, and it can't. So I know it's going to be negative, which means it's going to have to go towards negative infinity, and then it's going to get very close to 0. And that's the graph of my function.